And we are live. What is up, everyone? Tyler here, back with another video. Whether you're watching this on Twitch as it happens or after the fact on YouTube, good to have you hanging out with me today. Let me adjust my lighting just a tad. And what we are going to do today is some more Rust programming. So I would encourage you, if you missed the past couple of weeks, you might feel a little bit lost. You might learn something either way. But if you've been with me, this is day number 3, if my memory serves me correct, of us attempting to learn Rust programming together. And so without any further ado, let's just dive into it. Let me go ahead and share my screen. There we go. And for those of you watching on Twitch, if you can just let me know if audio, video, everything looks good to you guys. What we are doing, if you missed the past couple of days, is we are just going through the official Rust documentation. So if you just like Google Rust book, this should come up. It's the official documentation for the Rust programming language, and it's really well done. But here's the thing, and I said this at the beginning of each video so far, if you stumbled across this video and you're looking to learn from an expert how to program in Rust, you have stumbled across the wrong person. I am nothing close to an expert. I am literally learning as we do this. So I'm reading through this book verbatim, and we're doing the code right alongside of it, and I'm making mistakes as I go. But I'm learning, and hopefully you're doing it along with me, and kind of like we're sitting together and learning how to program together is how I kind of picture this, at least in my head. And what up, Crazy Goose? Shout out to you. He said sounds and looks good. Glad it sounds good. And for those of you joining, I would love to know from you guys on Twitch, do you have any experience programming in Rust? And if not, what brought you to the Twitch channel? Usually I hack stuff. I've taken a little bit of break from hacking. I'll be back into that probably in the next stream. I'll take a break from Rust and do some more hacking. But it's fun to change it up and focus on programming just a little bit. Now, here's what we've covered so far. So we covered all of chapter 1. We covered all of chapter 2, which is when we programmed a guessing game. And we're working our way through chapter 3. My goal today is to hopefully finish chapter 3. I'm going to go about 1 hour. So an hour from now, we'll see where we're at. But hopefully we can get through functions, comments, and control flow. Last night we did variables, immutability, and data types. So let's dig into functions. And I'll also keep my eye on the Twitch chat. Would love to interact with you guys joining me on Twitch. Crazy Goose said, no experience in Rust, but I am almost done with this JavaScript bootcamp. I don't remember when I followed this channel. What do you think about the JavaScript bootcamp? I know a little bit of JavaScript. I'm not awesome at it. I did like an online course on JavaScript just so I understood it better for web app pen testing. So I'm not awesome with it, but I understand at least the basics of the syntax, and I know how to read it. That's about all I can do with JavaScript. Crazy Goose, do you want to be a web designer? Is that why you did a JavaScript bootcamp? I'm guessing. All right, let's dive in. Functions. Functions are prevalent in Rust code. You've already seen one of the most important functions in the language, the main function, which we have right here. I have my code set up, and I should explain this. What I'm doing on line number 1 is we are grabbing std, which stands for standard library, and io for it's not input, output, I don't think, but it's how we can read stuff from the user. That was from the previous program. I don't know if we're going to use that library or not, but we'll just leave it up there just in case we do. The main function, which is the entry point of many programs. You've also seen the fn keyword, which allows you to declare new variables. All right. Rust code uses snake case as the conventional style for function and variable names, in which all letters are lowercase and underscores separate words. Here's a program that contains an example function definition, and it's always good to follow along while you're learning the code. Type it all out, even if it's just an example, just so we can build that muscle memory. So let's go ahead and type this out. We are doing print line, which we have done a bunch so far. Hello world, like that. And then it says another function. Obviously, nothing is in that function from what I can see. And then we're closing. So we're closing that one out. I see, because that's all in the main function. And then we're defining another function here, just like we defined main up above. Nothing there. Do our curly brackets. 4 spaces is the proper way. 1, 2, 3, 4. You could use an IDE. It does some of that stuff for you. As I'm learning the programming language, I like to just use a basic text editor because it forces you to learn some of that syntax manually. Print line, another function. And there we go. We just made another function. So we F in main. Inside of main is calling another function, and then here is another function, which is another function. What happens if we run this? Let's just try it. So let's go ahead and save this. Let's go to our terminal right here, and I think I'm in here. So now if we do cargo run. Okay, so we can see we have some warnings. That doesn't mean, this confused me in the last stream. For those of you who are watching or on YouTube, I thought, hey, my program didn't compile, but you have to pay attention to the kind of the coloring. It's just a warning, and it's saying we did not use our standard library, which is fine. We didn't have any need to use it. Warn is on by default, but it said hello world, and it said another function. So it just called those two print line things as well, and you can see that's how we did it. So I think the reason it worked that way is in the main function, we did hello world, and within the main function, we called our another function, then we defined the another function down here, so it must not matter as much where you define it. I'm gonna jump over to chat. Crazy Goose says, it was a lot of info thrown at me, learned a lot along the way, currently learning React. I'm trying to get into cybersecurity, thought it would be helpful, military paid for it, so I don't mind. Very cool. So JavaScript is actually really helpful to get into cybersecurity. My role right now is I am an associate pen tester. I do mainly web app pen testing. I do some external pen tests. Hopefully I'll be able to move into internal pen tests soon. But one of the first roles, if you want to get into pen testing at least, is almost always web apps and APIs. And anything like JavaScript is really going to help you understand web app pen testing better. So keep it up. It's an excellent language to dig into if you want to get into at least the offensive side or even the defensive side. JavaScript is good because it's so prevalent in different web apps. All right, we define a function in Rust by entering fn, which we did, followed by a function name and a set of parentheses. The curly brackets tell the compiler where the function body begins and where it ends. We can call any function we've defined by entering its name followed by a set of parentheses. So right here, we are calling the another function. Let's see, I lost where I was at. There we go. Because another function is defined in the program, it can be called from inside the main function. Note that we defined another function after the main function in the source code. We could have defined it before as well. Rust doesn't care where you define your functions, only that they're defined somewhere in a scope that can be seen by the caller. So like I was saying, it doesn't matter what order it's in. Let's start a new binary project named functions to explain functions further. Place the another function example in that and run it. You should see the following output. Well, let's go ahead and just copy this for now. And if we go down to our terminal, let's see, ls, and we will make a directory and we will, well, no, we won't make a directory. Is it just cargo new? I can't remember if it makes a directory for us or not. Cargo new functions. I think we have to make the directory first now that I'm thinking of it. Make directory functions, cd functions, and then it's cargo new functions. Does that do the job for us? Oh, it did create the directory. Now we have two directories. Okay, let's go like this. Let's move functions and we'll move it out. Okay, whatever. This works. We have that cd source. And if we do Pluma, oh, we already have it open. Oh, Pluma main rs ampersand like that. And we should just be able to copy in our code there. We'll save it. And now let's just see if everything worked in the weird way that I did it. And it did. Hello world and another function. It worked properly. Cool stuff. Of course, we don't need this at the top. I suppose we can delete this. If we delete that, it should erase that error message we were getting. Whoops. Let's just try it. Well, let's try that. There we go. Now we don't have any error messages. It compiles properly. Hello world and another function. Parameters. We can define functions to have parameters, which are special variables that are part of a function's signature. When a function has parameters, you can provide it with concrete values for those parameters. Technically, the concrete values are called arguments, but in casual conversation, people tend to use the words parameter and argument interchangeably for either variables in the function's definition or the concrete values passed in when you call a function. In this version of another function, we add a parameter. Okay. So fn main, which is fine. So we're taking out our hello world from what I can see. We can go like that. And in our another function, we are adding a parameter for 5. So let's go ahead and add that. And then we have fn another function. We're adding another parameter here. It looks like we're defining x, and we're defining the type of x. We're saying it's I32, which if I remember right, means signed, which means it can be positive or negative, if I remember right from yesterday when we were going through this. And then we're printing a line here, and it looks like we're saying the value of x is, and then we're pulling that value in there like so. Try running this program. You should get the following output. Let's see if everything looks good. We have another function, 5, all that, and we should get the value of x is 5. And why is that? Well, we have another function here, and we're passing it 5. So in main, I'm just trying to understand this. So we're actually defining the function here. And we're defining the function, we're specifying the type that x should be, and then we're saying the value of x is x. But we're just defining the function there, whereas right here, we're calling the function and then passing the parameter. So we're telling the function, hey, we want x, what we defined down here, to be 5. So therefore, when you call this function here, it's going to replace this with 5 and replace with this 5 as well. At least that's makes sense in my head. Let's see if it does it. Oh, I should probably save it. Let's Control S, and now let's try it. The value of is 5. What did I do? The value of is 5. The value of x is 5. Other than that, we did it correctly. The declaration of another function has one parameter named x. The type of x is specified as I32. When we pass 5 into another function, the print line macro puts 5 where the pair of curly brackets containing x was in the format string. In function signatures, you must declare the type of each parameter. This is a deliberate decision in Rust design. Requiring type annotations and function definitions means the compiler almost never needs you to use them elsewhere in the code to figure out what type you mean. The compiler is also able to give more helpful error message if it knows what types the function expects. And that's one thing I've noticed about Rust. The error messages are actually really helpful. They're not as mysterious as some other compiled languages. When defining multiple parameters, separate the parameter declarations with commas like this. And once again, let's type all of this out. Let's just even go back to here, and let's type all of it ourselves to build that muscle memory. So our first function is print labeled measurement 5h. I'm guessing that is going to stand for height in this. And then we're defining another function down. So that's the main function up there. And the main function is calling this function, but it's not actually defined yet. So now we're going to define the function that's being called. Print labeled measurements. Measurement is not S. Let's go up there and delete that. Print labeled measurement value. And we're defining the type right there with I32. And then unit label character. So we're giving it a value, and also, well, we have to define two types, right? We have to define this one here, which is the value I32, and then H is a character, so we have to define the type there as well. That makes sense. Now let's do our 4 spaces, 1, 2, 3, 4, and print line. Calling the print feature, the measurement is pass on value, and pass on unit label like that. So once again, let me go and close my curly brackets. Even if I can just add comments, right? So like that. Here we are defining the function. So we're defining it here, but it's actually being called up here. And what it's going to do is it's going to pass the 5 and the H into these two areas. So we're defining the types here, but it should print the measurement is 5H, I believe is how it should come out. Let's go ahead and save that, and let's do our cargo run. The measurement is 5H. Sure enough, it worked. We didn't have any typos. That's impressive. This example creates a function named print labeled measurement with two parameters. The first parameter is named value and is an I32 signed number. Signed, if you guys remember from yesterday, signed doesn't mean like a signature, it just means it has a sign before it. So a signed number can be positive or negative, an unsigned number can only be positive. The I tells us it's a signed number, I believe. Hopefully I'm not wrong on that. The second is named unit label and is type character. The function then prints text containing both the value and the unit label. Let's try running this code. Replace the program currently in your functions project with the preceding example and run it using cargo run. We already did that. Worked fantastic. Because we call the function with 5 as the value for value and h as the value for unit label, the program output contains those values. Statements and expressions. Function bodies are made up of a series of statements optionally ending in an expression. So far, the functions we have covered haven't included an ending expression, but you have seen an expression as part of a statement. Because Rust is an expression-based language, this is an important distinction to understand. Other languages don't have the same distinction, so let's look at what statements and expressions are and how their differences affect the bodies of functions. All right, statements. Statements are instructions that perform some action and do not return a value. Got it. Expressions evaluate to a resultant value. Let's look at some examples. Let's do it. Let's go ahead and erase our stuff up to here. Like that, we'll have to remember to add our curly brace. So let y equal 6. Let me just add this before I forget. A main function declaration containing one statement. So this is a statement because it performs some action, doesn't return a value. If we just run this, nothing's going to happen. We have to print y in order for it to happen. That makes sense. So it's a statement. Function definitions are also statements. The entire preceding example is a statement in itself. Statements do not return values. Therefore, you can't assign a let statement to another variable, as the following code tries to do. You'll get an error. So let x equals, let y equals 6. Okay, well that makes sense that you can't do that. When you run this program, the error you'll get looks like this. Expected expression, found statement, let. Variable declaration using let is a statement. Let expression, this position are unstable. It freaks out, right? Which makes sense. The let y equals 6 statement does not return a value. So there isn't anything for x to bind to. This is different from what happens in other languages such as C and Ruby, where the assignment returns the value of the assignment. In those languages, you can write x equals y equals 6 and have both x and y have the value 6. That is not the case in Rust. Expressions evaluate to a value and make up most of the rest of the code that you'll write in Rust. Consider a math operation such as 5 plus 6, which is an expression that evaluates to the value 11. Expressions can be part of statements. This is an expression. Okay. In listing 3-1, is this 3-1? I don't know. They're not actually labeled. Oh well. The 6 in the statement, let y equal 6, is an expression that evaluates to the value 6. Calling a function is an expression. Calling a macro is an expression. A new scope block created with curly brackets is an expression. For example. All right, so let's go ahead and do this. We have main, and we're saying let y equals 1, 2, 3, 4. Let x equal 3. Okay, and then x plus 1. Close our curly brackets. Let y, Does this actually come out? I need to add the print line. Let y equal, and then in curly brackets, let x equals 3 and x plus 1. Let y equal this. So is y going to equal 4? I don't know. Okay, this will be interesting. Print line. The value of y is y. Of course it is. This expression, that is a block that, in this case, a value is to 4. So right on that value gets bound to y. So I was right as part of the let statement. Note that the x plus 1 line doesn't have a semicolon at the end, which is unlike most of the lines you've seen so far. Expressions do not include ending semicolons. If you add a semicolon to the end of an expression, you turn it into a statement, and it will then not return a value. Keep this in mind as you explore function return values and expressions next. That is kind of confusing. I'm sure with practice we get it. Let's go ahead and run our code and see if it compiles properly. Yeah, it does. The value of y is 4. So we read the code properly. That's a win. Although expressions and statements are a little bit confusing. Statements do not produce a value, expressions do. I'm trying to think of a good way to think about that. I would think I have 2 young kids, right? Usually they express themselves by getting angry at each other and crying. And when they express themselves, they produce something, tears or laughter or joy, right? That's an expression that produces something. That's how I'll keep it straight in my own head. An expression produces something, kind of like when a person expresses anger, it usually produces a red face or yelling, right? It has a production value to it. Functions with return values. Functions can return values to the code that calls them. We don't name return values, but we must declare their type after an arrow. In Rust, the return value of the function is synonymous with the value of the final expression in the block of the body of a function. You can return early from a function by using the return keyword and specifying a value, but most functions return the last expression implicitly. Here's an example of a function that returns a value. Okay, let's go ahead and write this all out ourselves. So we actually are going to put this apparently before the main function. So let's go up here and we'll say fin 5. So we're defining a function called 5. And we are saying we want it to be an i32 value. Go like this, 1, 2, 3, 4, 5. And then we're defining it as a 5 there. Hopefully that makes sense. What we are doing here, let 5 equal. We're defining the type, which is a signed 32 number. And then we're giving the value right there is 5. Now we have our fin main function right here, and we're saying let x equals 5, like that, and then print line the value of x is, and it should compile to 5, I would assume. Let's save it. Yeah, well, I spelled value wrong, but it did work. Value of x is 5. There are no function calls, macros, or even let statements in the 5 function. Oh, there are no function calls, macros, even let statements in the 5 function. Just the number 5 by itself. That's a perfectly valid function in Rust. Note that the function's return type is specified too as i32. Try running this code. The output should look like this, which we already did. The 5 in 5 is the function's return value, which is why the return type is i32. Let's examine this in more detail. There are 2 important bits. First, the line let x equals 5 shows that we're using the return value of a function to initialize a variable. Let x equal, okay, that makes sense, yep. Because the function 5 returns a 5, that line is the same as the following, let x equals 5. Second, the 5 function has no parameters and defines the type of the return value. The 5 function has no parameters, defines the type of the return value. Yep, that makes sense. But the body of the function is a lonely 5 with no semicolon because it's an expression whose value we want to return. Let's look at another example. We can delete this. It looks like we are starting with main this time. So let's start with our main right here. I'm going to turn my desktop audio down so you guys don't hear Parrot beep at us when we type something wrong. Let x equals plus 1, 5. Okay, so what are we doing here? We are defining the value of x to be the function call plus 1 and passing it a 5 parameter. So we have to, of course, define that, which I'm sure we will. And then we're doing print line value of x is, geez, why do I always do is? The value of x is, even while I'm saying it, I type it wrong. Isn't that interesting? And now we have to define this function that we're calling up there. So fn for function, We're defining the +1 function. First, we're going to define the type of the number, which is assigned 32. Our arrow key, our little arrow thing, not really an arrow key, but we're going to create our arrow because we're saying we want this to return a value. And we want to return an I32 value like this. Oh, this is interesting. 1, 2, 3, 4, x plus 1. Okay, let's try to guess before we run the program. What is this going to do? Well, here we're passing it the parameter of 5, which is right here. We know it's an I32, but then it's going to take 5 plus 1, so it's actually going to be 6. When it calls this function, it's going to pass it 5, which is x. 5 plus 1 equals 6, so the value of x is 6. At least that's how it makes sense in my own head. Let's go ahead and run the program. Yeah, the value of x is 6. That makes sense. Running this code will print the value of x is 6, but if we place a semicolon at the end of the line containing x plus 1, let's do that. Changing it from an expression to a statement, we'll get an error. Okay, let's go ahead and get that error and let's read through it. Okay, what is our error? Mismatch types fn plus 1, expected I32, but found that. Implicitly returns that as its body has no trail or return expression. X plus 1 cannot compile functions due to previous error. Remove this semicolon to return this value. And isn't that helpful? Like, I don't know if you guys notice how much more helpful Rust's errors are than other languages. It specifically tells us, like, remove this semicolon to return this value. Thank you for the help. Appreciate Rust. You are actually a really helpful program. We have our cool little crab guy there. The main error message, mismatch types, reveals the core issue with this code. The definition of the function +1 says it will return an I32 or signed 32 number, but statements don't evaluate to a value which is expressed by the parentheses, the unit type. Therefore, nothing is returned, which contradicts the function definition and results in an error. In this output, Rust provides a message to possibly help rectify this issue. It suggests removing the semicolon, which would fix the error. Good job, Rust. All right, let's talk about comments. All programmers strive to make their code easy to understand, but sometimes extra explanation is warranted. In these cases, programmers leave comments in their source code that the compiler will ignore, but people reading the source code may find useful. Here's a simple comment. We already made our own comment before, / hello world. Easy enough, and we can type this stuff, I suppose. Why not? Let's just delete all of that so we have to retype it, right? Hello world. That's not going to be picked up by the program. In Rust, the idiomatic comment style starts a comment with 2 slashes, and the comment continues until the end of the line. For comments that extend beyond a single line, you'll need to include / on each line like this. Hello, everyone. Welcome to my Twitch channel. If you are watching this on YouTube, please subscribe. There we go. Double comments. So we're doing something complicated here. Long enough, blah, blah. Comments can also be placed at the ends of lines of code. So let's go ahead and do that. So we're going to define our main function. Let lucky number equal 7. And now we're adding a code. I'm feeling lucky today. Yes, we are. And let's close it with our semicolon like that. But you'll more often see them used in this format with a comment on a separate line above the code is annotating, which just looks cleaner to me. I apparently don't know how to type. It looks cleaner to me to see it on a separate line or to annotate above your code, kind of what this code is doing. Rust also has another kind of comment, documentation comments, which we'll discuss in Publishing a Crate to Crates IO section of chapter 14. Hey, we're doing good, although this looks like a longer chapter. We have 30 minutes. I think we can make it through control flow. Let's see how we do. The ability to run some code depending on whether a condition is true and to run some code repeatedly while a condition is true are basic building blocks in most programming languages. The most common constructs that let you control the flow of execution of Rust code are if expressions and loops. If expression. An if expression allows you to branch your code depending on conditions. You provide a condition and then state if this condition is met, run this block of code. If the condition is not met, do not run this block of code. Create a new project called branches in your project's directory to explore the if expression. All right. let's go ahead and do that. I guess we can save it, and then we can close this. Just close this in general. Let's see, CD back to functions, and cargo new, and what are we calling it? Branches? Yeah, branches. And now we can pluma main ampersand. Like that. Bring it over here. And here we have this f in main. Let's go ahead and follow along with it and speak it out loud, teach it as we do it so we understand what's going on. So we're defining a variable and we're giving it the value of 3. Okay, makes sense so far. If our number, I remember this from school, the greater than and less than, I don't know if you guys learned this in school. I was always taught this is like an alligator mouth, and the alligator always wants to eat the bigger number, right? So in other words, if our number is less than 5, because the alligator's eating, the bigger number, 5. Silliness. So if our number is less than 5, which 3 is of course less than 5, 1, 2, 3, 4, then we want to print a line. Condition was true. Okay, that makes sense. And looks like we're gonna actually close that like that, and then else, our else statement, print line, condition was false. Like that. Close that one. So we put the if and else statement inside of their own curly brackets, it would appear. So let's go ahead and save that, and let's run it and see if it compiles properly. Condition was true. Yep. So if number is less than 5, print condition was true. S-Brand over in the Twitch chat said, I was always taught Pac-Man, not alligator. Must be different parts of the country. Where I live, we're taught alligators. Even though I don't live in Florida or anything, that seems like something you would learn in Florida, since alligators seem to eat everybody in Florida. All if expressions start with the keyword if. Let's pull our code back up. There we go. All if expressions start with the keyword if, followed by a condition. In this case, the condition checks whether or not the variable number has a value less than 5. We place the block of code to execute if the condition is true immediately after the condition inside curly brackets. Blocks of code associated with the conditions and if expressions are sometimes called arms. Just like the arms in match expressions that we discussed in the comparing the guess to the secret number section of chapter 2. Optionally, we can also include an else expression, which we did, which we chose to do here to give the program an alternative block of code to execute should the condition evaluate to false. If you don't provide an else expression and the condition is false, the program will just skip the if block and move on to the next bit of code. Makes sense? Let's try changing the value of number to a value that makes the condition false to see what happens. All right, they did 7. We're going to do 1337 because we are elite hackers, right? The condition was false, which is what it should be, because if we look at our code, once again, 1337 is not less than 5, therefore the condition is false. It's also worth noting that the condition in this code must be a bool or a boolean. If the condition isn't a bool, we'll get an error. For example, try running the following code. Let number equals 3, and if number print line number was 3. I think we can all understand why that code doesn't evaluate. There's no comparison actually being done here. The if condition evaluates to a value of 3 this time, and Rust throws an error. Expected bool found an integer. The error indicates that Rust expected a bool but got an integer. Pretty obvious. Unlike languages such as Ruby and JavaScript, Rust will not automatically try to convert non-Boolean types to a Boolean. You must be explicit and always provide if with the Boolean as its condition. If we want the if code block to run only when a number is not equal to 0, for example, we can change the if expression to the following. Okay. Let's retype all of this. Once again, muscle memory is important. So we're defining our number variable as 3 again. If number does not equal, so if you're new to programming, you may not realize that that means does not equal, but that's what that means. If number does not equal 0, then we want you to run this code. print line, like that. Number was something other than 0. And then close our curly bracket there, save it, and that should be the message it gives us. Number was something other than 0. Beautiful. Running this code will print that. Handling multiple conditions with else if. You can use multiple conditions by combining if and else in an else if expression. For example, let's go ahead and follow along again. So let number equal 6. We're defining our number variable. We're calling it 6. And if our number is divisible, if the number it's not divisible, if the remainder of the number by 4 equals 0, all right, so that's the difference. To define a variable, usually it's one equal, but we're doing a comparison there. That's why there's 2 equals there. If you already know a little bit of Python or something, that'll make sense to you. 1, 2, 3, 4, add our spaces, print line. Number is divisible by 4, like that. And then we have to close our curly bracket. I'm totally going to have some type of typo in here, I guarantee. Else if number divisible by 3, or the remainder of being divisible by 3 equals 0, add our curly bracket again. Print line, number is divisible by 3. There we go. I'm going to close that one. Like that. Else if number, I'm sure you guys probably see a typo I've made by now and you're going to laugh at me when I attempt to run it. Like that. 1, 2, 3, 4. Print line, number is divisible by 2. Like that. Go back out to here, close our curly bracket, and then we have a final else, kind of like catch everything else. Print line, number is not divisible by 4, 3, or 2. And then one more curly bracket. Let's see if it runs properly. Number is divisible by 3, which 6 is divisible by 3. Beautiful. Surprised I didn't have a typo in there somewhere. The program has 4 possible paths it can take. After running it, you should see the following output. Number is divisible by 3. When this program executes, it checks each if expression in turn and executes the first body for which the condition evaluates it true. Note that even though 6 is divisible by 2, we don't see the output number is divisible by 2, nor do we see the number is not divisible by 4, 3, or 2 text from the else block. That's because Rust only executes the block for the first true condition, and once it finds one, it doesn't even check the rest. Using too many else if expressions can clutter your code, so if you have more than one, you might want to refactor your code. Chapter 6 describes a powerful Rust branching construct called match for these cases. Water break. All right. Using if in a let statement. All right, let's go ahead and use an if in a let statement. F in main, so we have our main function, let condition equal true. Condition's always going to be true, obviously. Let number equal if condition, this is interesting code. If condition 5 curly brackets else 6. So I think let number equals if condition, which I think is just a shorthand of saying if the condition is true, let number equal 5, else let it equal 6. So we're kind of doing an if-else statement, but all on one line, I think is what is going on there. Print line, the value of number is number. Like that. So we should be, if I'm understanding this correctly, we should get the value of number is 5. Yeah, the value of number is 5. That makes sense. It's just a shorthand way of writing that. The number variable will be bound to a value based on the outcome of the if expression. Run this code to see what happens. Remember, that blocks of code evaluate to the last expression in them, and numbers by themselves are also expressions. In this case, the value of the whole if expression depends on which block of code executes. This means the values that have the potential to be results from each arm of the if must be the same type. In listing 3-T2, the results of both the if arm and the else arm where I are signed 32 integers. If the types are mismatched, as in the following example, we'll get an error. Let's just look at this code. Let condition equal true. Let number equal if condition 5 else 6. All right, so we have an integer here and a string here. So that's why it's going to break. When we try to compile this code, we'll get an error. The if and else arms have value types that are incompatible, and Rust indicates exactly where to find the problem in the program. Right here, expected because of this, expected integer, founded string. The expression in the if block evaluates to an integer, and the expression in the else block evaluates to a string. This won't work because variables must have a single type, and Rust needs to know at compile time what type the number variable is. Definitely. Knowing the type of number lets the compiler verify the type is valid everywhere we use number. Rust wouldn't be able to do that if the type of number was only determined at runtime. The compiler would be more complex and would make fewer guarantees about the code if it had to keep track of multiple hypothetical types for any variable. Makes sense. Repetition with loops. It's often useful to execute a block of code more than once. For this task, Rust provides several loops which will run through the code inside the loop body to the end and then start immediately back at the beginning. To experiment with loops, let's make a new project called loops. All right, well, let's do it. Open up our terminal. Cargo, new loops, cd loops, cd source. We have main there, pluma, main.rs, ampersand. There we go. And let's go ahead and delete our initial line here. F in main, and we are defining a loop here. This looks like an infinite loop because there's nothing stopping the loop, right? Print line, and it's an infinite loop that's just going to say again, again, and again. Kind of sounds like a toddler. Let's save that. Let's run that infinite loop. Whoops. Cargo run. Yep, infinite loop. Oh no, we're going to die. It's going to break. There we go. We're good. But it is an infinite loop. When we run this program, we'll see again printed over and over continuously until we stop the program manually. Most terminals support the keyboard shortcut Control-C, which is what we did to interrupt a program that is stuck in a continual loop. Give it a try. The symbol *C represents when you press Control-C. You may or may not see the word again printed after the C, depending on where the code was in the loop when it received the interrupt signal. Fortunately, Rust also provides a way to break out of a loop using code. You can place the break keyword within the loop to tell the program when to stop executing the loop. Recall that we did this in the guessing game in the quit after a correct guess section of Chapter 2 to exit the program when the user won the game by guessing the correct number. We also use continue in the guessing game, which in a loop tells the program to skip over any remaining code in this iteration of the loop and go to the next iteration. Returning values from loops. One of the uses of a loop is to retry an operation you know might fail, such as checking whether a thread has completed its job. You might also need to pass the result of that operation out of the loop to the rest of your code. To do this, you can add the value you want returned after the break expression you used to stop the loop. That value will be returned out of the loop so you can use it as shown here. Okay. Well, let's go ahead and give this a shot. So let mute. So we're making a variable that's mutable, which means it's able to be changed. And the variable's name is counter, and it's 0. And let result. So we're setting a new variable called result. And this is going to be defined by a loop, it would appear. Counter, we're adding 1 to counter each time as it runs through the loop. As you can see, that plus equals a shorthand of way. We could also say counter equals counter plus 1 would be the long way, but plus equals works as well. Like that. And we'll jump down a line. And we're doing an if statement. If counter equals 10. So once counter gets to 10, here's what we want it to do. We want it to break. So we want it to break at that spot and take the counter and times it by 2, which means it should make the counter be 20. I would think, at least that's where it works in my head. And we have to close this too right here. I think I have that right. And then finally, once we break out of all of it, we want to print line and say the result is result. Like that. Okay, so if I'm understanding the code properly, we're setting a counter variable to 0. And then we're setting the result in a loop. And what the result is going to do, well, let result equals loop. Okay, and then result is going to be defined by taking the counter, which is 0, adding 1 to it. Once the counter equals 10, we're going to break, we're going to get out of it and take the counter times 2, which is going to make it 20. And then the result is result. Oh, so then we're pulling the result down right there. So yes, result would be 20. It's just we're defining result in a weird way by using counter, which was defined up there. It should still be 20 though, at least in my head. That's what makes sense. Let's try it ourselves. Yeah, we have a warning here. Oh, I have a double semicolon, but it didn't break. I'll just have to remove that. But the result is 20. Where's our double semicolon? There it is. I'm glad I didn't break the program. Before the loop, we declare a variable named counter and initialize it to 0. Then we declare a variable named result to hold the value returned from the loop. On every iteration of the loop, we add 1 to the counter variable and then check whether the counter is equal to 10. When it is, we use the break keyword with the value counter times 2. After the loop, we use a semicolon to end the statement that assigns a value to result. Finally, we print the value in result, which in this case is 20. Loop labels disambiguate between multiple loops. If you have loops within loops, break and continue apply to the innermost loop at that point. Okay? You can optionally specify a loop label on a loop that you can use with break or continue to specify that those keywords apply to the labeled loop instead of the innermost loop. That makes sense? Loop labels must begin with a single quote. Here's an example with 2 nested loops. All right. Once again, type it all out, build our muscle memory. We are defining our count variable again. It's mutable. And here is a label. We're starting with a single thing there, single quote. Counting up is the label of it. And then we're going to define what that is, which is a loop right here. Print line count equals count. So we're calling the count variable. Makes sense. Let mute remaining equal 10. All right, let's see if we understand this so far. We have our count variable, and now we're labeling this next loop. We're giving it a name essentially called counter up. And that loop is going to say count equals count. So it's going to say count equals 0. And then let mute remaining. We're defining a new variable called remaining, and we're setting it to 10. As in we have 10 things remaining. Maybe it'll make sense once we get to the rest of our code. We have another loop inside of that loop. Print line remaining equals remaining, like that. So then we have another loop saying remaining equals remaining, which would be 10 at this point. If remaining equals 9, so if it goes down 1, what do we want it to do? Well, it looks like we want it to break. We want it to go to the next iteration. We want it to get out of this inner loop, I think, if I'm understanding that correctly. If count equals 2, or if count, not counter, if count equals 2, what do we want to do if our count value gets to 2? We want break. So now we're breaking out of counting up. We're breaking out of this loop up here, and you can see usually if we're doing this, it would only break out of the innermost loop, but because we're calling it by name, we can break out of this loop that's up here, is what it's teaching us, I think. Close that out. And remaining minus equal 1. So then we are taking 1 from remaining. Okay. remaining equals remaining. If remaining equals 9, break. If count equals that, and then remaining minus equals 1, we're taking 1, subtracting 1 from remaining. Got it? Hopefully I'm getting all my spaces correct here. This is confusing even while I look at it. Drop down, count plus equals 1. Then we're adding 1 to count. Okay. Add that. And then finally, print line and count equals count. Let's see if we can understand this ourselves before we run it. F in main, so we're defining a variable called count. It's mutable, which means it can change. We're setting it to 0. Then we have this loop that we're giving a label to called counter up. And this loop is going to first print count equals count. So whatever's in our count variable, it's going to print that. And it's also defining this second variable called remaining, and we're equaling it to 10. Then we have another loop here within this main function where it's going to print a line saying remaining equals remaining, which is 10. Now, if remaining ever equals 9, we are going to break out of this. Are we going to break out of this loop? And go break out of this loop and go to this one, subtract 1 from remaining. If count equals 2, break counting up and count, add 1 to count. So each time it's going to subtract 1 from remaining and add 1 to count. That's what it's doing. Taking 1 from remaining, add 1 to count, and then we're going to have our end counter here. It's kind of confusing. Okay, so we have some errors here. Undeclared label counting up. Help. Try using similarly named label counter up. Oh, I just have a typo there. Counter up, and it needs to be counting up. Does that fix my errors? Yeah. Okay, so count equals 0, remaining equals 10, and then of course it subtracts 1, remaining equals 9, count equals 1. Remaining equals 10, remaining equals 9, count equals 2, remaining equals 10, and counter equals 2. I don't know if I if I did that properly. Oh no, I guess it does. I guess it looks the same as theirs, doesn't it? Let's try to really understand this. The outer label has the label counting up, and it will count up from 0 to 2. Oh yeah, because if count equals 2 and if count equals 9, so it's not going to go beyond those things. The inner loop without a label counts down from 10 to 9. The first break that doesn't specify a label will exit the inner loop only. Right there. The break counting up statement will exit the outer loop, and this code prints this. Okay? Kind of makes sense. Oh, 1 second. I got a message on Discord. Meeting with my friend Amoeba Man. I thought it would be later, but he's already online. So I'll be wrapping up soon because he and I are going to talk about some cool hacking stuff, just not live on stream. But okay, let's keep working through this. I'll exit this code, prints that. Conditional loops with while. Sign this message one more time. Okay. Conditional loops with while. A program will often need to evaluate a condition within a loop. While the condition is true, the loop runs. When the condition ceases to be true, the program calls break, stopping the loop. It's possible to implement behavior like this using a combination of loop, if, else, and break. You should try that now in a program if you'd like. However, this pattern is so common that Rust has a built-in language construct for it called a while loop, which makes sense. It's common in a lot of programming languages. In listing 3-3, we use while to loop the program 3 times. Okay, I was just glancing over at my chat. 3 times, counting down each time, and then after the loop, print a message and then exit. How much more do we have left? Okay, we don't have too much more left. I need to read through this because I was distracted. If you like, however, this pattern is so common, Rust has a built-in program called while loop. We use the while loop to program 3 times, counting down each time, and then after the loop, print a message and exit. All right, let's go ahead and try that. Let mute number equal 3, like that. And while our number does not equal 0, what do we want it to do? Print line like this. So while it doesn't equal 0, we just want it to print number. Okay, and then we are going to subtract 1 from our number variable. So it's not an infinite loop. There, I think I have my spacing right there. And print line, lift off. Oh, it's going to count down, I see. So it's going to count down because while we need to specify number here, we almost missed our variable. While our number does not equal 0, it's just going to print the number, and then it's going to subtract 1. So it should go 3, 2, 1, lift off. Let's see what happens. Hope you guys like my sound effects there. 3, 2, 1, lift off. We're flying through the sky now. This construct eliminates a lot of nesting that would be necessary if you use a loop, if, else, and break, and it's clear. While condition evaluates it true, the code runs, otherwise it exits the loop. Looping through a collection with for. You can choose to use the while construct to loop over the elements of a collection, such as an array. For example, the loop in listing 3-4 prints each element in the array A. And guys, just for the sake of time, we are at an hour, and I wanted to wrap up an hour. I'm just going to read through the rest of this rather than typing it all out, but we'll still do our best to understand it. So we're defining a function called main. We are defining our array here with 10, 20, 30, 40, 50. Let mutable index, or setting an index variable that's mutable and it's equaling 0. While our index is less than 5, we want to print the value is, and we're pulling this out, of index. So first it's going to be 10, 20, 30, 40, 50, because we're going to add to it. So the first time it's going to be a 0, which remember computers count 0, 1, 2, 3, 4. So it should repeat all of those numbers when it prints out. Here, the code counts up through the elements in the array. It starts at index 0 and then loops until it reaches the final index in the array. That is when index less than 5 is no longer true. Running this code will print every element in the array. All right, I understand that. All 5 array values appear in the terminal as expected, even though index will reach a value of 5 at some point. The loop stops executing before trying to fetch a 6 value from the array. However, this approach is error-prone. We could cause the program to panic if the index value or test condition is incorrect, because remember, if we have an index outside of what's available, we panic. For example, if you change the definition of the A array to have 4 elements but forgot to update the condition of while index is less than 4, the code would panic. It's also slow because the compiler adds runtime code to perform the conditional check of whether the index is within the bounds of the array on every iteration through the loop. As a more concise alternative, you can use a for loop and execute some code for each item in a collection. Okay, so f in main, same thing. For element in A. If you've ever used a for element or a for loop, each one of these, the element could be anything. We call it kitty cat, right? But it's going to say these are the elements. For each element in A, the value is element. So it's going to loop through here. 10, 20, 30, 40, 50. Very similar to Python and other coding languages there. While we run this code, we'll see the same output. More importantly, we've now increased the safety of the code and eliminated the chance that bugs might result from going beyond the end of the array or not going far enough and missing some items. Using the for loop, you wouldn't need to remember to change any other code if you change the number of values in the array as you would with the method used in listing 3-4. The safety and conciseness of for loops make the most commonly used loop construct in Rust. Even in situations in which you want to run some code a certain number of times, as in the countdown example 3, 2, 1 liftoff that used a while loop, most Rusticians, I forgot how someone corrected me on YouTube and I don't remember how they told me to pronounce that, but Rusticians or something, would use a for loop. The way to do that would be to use a range provided by the standard library, which generates all numbers in a sequence starting from one number and ending before another number. Okay, once again, we have range in Python. Here's what the countdown would look like using a for loop and another method we've not yet talked about, rev, to reverse the range. So for number in, here's our range, 1 to 4, reverse. So 4, 3, 2, 1. I see what it's doing there. We're calling reverse on the range 1 to 4 and for number, print line, number. So that's going to go 4, 3, 2, 1, liftoff. The code is a bit nicer, isn't it? Summary. We made it. This was a sizable chapter. You learn about variables, scalar and compound data types, functions, comments, if expressions, and loops. To practice with the concepts discussed in this chapter, try building programs to do the following. Ooh, maybe we can do this on our next stream. Convert temperatures between Fahrenheit and Celsius, generate the nth Fibonacci number, and print the lyrics to the Christmas Carol, The 12 Days of Christmas, taking advantage of the repetition in the song. Wow. When you're ready to move on, we'll talk about a concept in Rust that doesn't commonly exist in other programming languages, ownership. Maybe in our next Rust stream, we'll try to work our way through these challenges and get frustrated in the process, but also see what we can learn. Glancing over at the chat, the cynical dunk said, hey, Tyler, I sit for the AZ900 tomorrow and am in my head about it, trying to find good resources to cram with. Hope you guys are staying warm. Thanks, man. I actually took the AZ900 a few months ago. You will do good. At least I think you will. If you have any cloud experience, it's very much a generic cloud. If you know cloud in general, it's just understanding how Microsoft defines those cloud terms. So you'll do a good job. The documentation I used was the official Learn documentation from Microsoft. And then there's another resource. I can't think of it, but there were practice tests that were really helpful for me to understand the concepts. I just don't remember the website that I was looking at, but you could buy some practice tests from them. They also had a full online course for AZ900 as well. But good luck. Let me know how it goes, guys. I'm going to sign off. It's been an hour and 6 minutes. Thank you for hanging out with me tonight. Hope you guys have an incredible Christmas this weekend. I'm not sure if I'll be streaming or not. I might not be streaming until next week with Christmas and holidays and all that good stuff, but hopefully you guys have an awesome Christmas, and I will catch you guys next time. See ya.